Students, today topic is lesson number 2, basic algebra. Real number system first. We shall recall how the real number system was developed. We start with the natural numbers. Natural numbers are n is equal to the set of all 1, 2, 3, 4 and so on. Whole numbers w is equal to 0, 1, 2, 3 and so on. Real numbers r is equal to the set of all 0, plus or minus 1, plus or minus 2, plus or minus 3 and so on to plus or minus infinity. Rational numbers minus 5, minus 7 by 3, 0, 22 by 7, 7, 12. All are rational numbers. Irrational numbers root 2, root 7, root 5 are the irrational number. Note, n natural number is a subset of w is a subset of z is a subset of q is a subset of real numbers. This is basic concept. Okay, absolute value. Next we are going to take absolute value of modulus x. Modulus x meaning x if x is greater than or equal to 0, minus x if x is less than 0. There are two possibilities. One is positive, another one is negative x. Next time, inequalities involving absolute values. Absolute values are mod x is positive x and negative x. Positive x if x is greater than 0, negative x if x is less than 0. In this case, inequalities, there are two types. One is mod x is less than or, and another one is mod x is greater than or, less than or greater than or. Okay, ex number 2.1, sum number 1, classify each element of the set root 7. Next minus 1 by 4, 0, 3.14, comma 4, comma 22 by 7, or the numbers of of n, q means rational. Next r minus single and 0, irrational integers. Number 1. First root 7, 4 is an element of the natural number set. 4 belongs to n. 4 is a number. 4 is natural number. Next, subdivision number 2, minus 1 by 4, comma 0 belongs to q. So minus 1 by 4 and 0 are the rational numbers. Next subdivision number 3, root 7, root 5 belongs to r minus q. Root 5, root 7, comma root 5 are the irrational numbers. Next, subdivision number 4, 0, 4 belongs to set are the integers. 0 and 4 are the integer. In this case 4 belongs to integer. Since 4 belongs to integer, or 4 is a natural number. Natural number set is a subset of integer. Okay. Therefore, we have to take 4 is an integer. Already known 4 belongs to natural number set. Okay. So the natural number set is a subset of integer. Therefore, it belongs to integer. Number 2. Question number 2. Prove that root 3 is an irrational number. Let us assume that root 3 is rational. Root is irrational, but we have to take rational. Root 3 is rational means p by q are the form. Okay, it is root 3 is a rational number of the form p by q. P by q. Squaring on both sides, 3 is equal to p square divided by q square. Cross multiplying, p square is equal to 3q square. But this is 1. In this case, q is an integer. Q is an integer. Q is an integer. Q square is an integer. Q square is integer multiplied by constant 3q square is an integer. Okay. Now p is an integer. Equation number 1. P is an integer multiplied by 3. So p square is an integer multiplied by 3. So p is equal to 3 into some number. N is some number in equation number 1. N is integer. Therefore, 3n square in equation number 1. 3n square is equal to 3q square. 9n square is equal to 3q square. So 3n square is equal to q square. Q square is an integral of q square is an integral value multiplied by 3. So this is a contradiction. Integral value multiplied by 3 is an irrational number, but in this case we have to take a rational number, therefore contradiction. So our assumption is wrong. Our assumption is wrong. Therefore, root 3 is an irrational is the result. Sum number 3. Or that the distinct irrational numbers such that their difference is a rational number. Is a rational number. Justify words. Justify your answer. 2 distinct irrational numbers may be rational or irrational. Rational or, this is concept, rational or irrational. Take the irrational numbers. Take the irrational, 2 irrational numbers. Take the 2 irrational numbers, 2 plus root 3 and then root 3. Difference is equal to 2 plus root 3 minus of root 3. So 2 plus root 3 minus root 3. Cancelling these 2, we get 2. 2 is a rational number. 2 is rational number. Take 2 irrational numbers. Plus root 3 comma minus 2 plus root 3. Difference is equal to 2 plus root 3 minus 2 plus root 3 is equal to 2 plus root 3 minus of minus plus 2 minus root 3. So these are cancelled, we get 4. 4 is rational. Is rational number. Therefore, the 2 numbers difference is rational number. Okay, next question number 4. Find the irrational number. Such that their sum is a rational number. Sum is rational number. Can you find 2 irrational numbers whose product is object is a rational number. Let the two rational numbers be 7 plus root 3 and 7 minus root 3. Sum is equal to 7 plus root 3 plus 7 minus root 3. Root 3 cancel. We get 14. 14, which is a rational number. Which is a rational number. Next, let the two rational numbers be one is root 3, another one is root 2, and then root 3 or root 8. Anyone? Product is equal to root 2 into root 8 is equal to root 16. Root 16 is rational. Root 16 is a rational number. Since 16 is a perfect square. Okay, sum number 4. Positive number. Find a positive number smaller than 1 by 2 power 1000. Justify. Let the number be given number. Let the number be 1 by 2 power 1000. We know that 1000 is less than 1001. Next line, 2 to the power of 1000 is less than 2 to the power of 1001. 1 by 2 to the power of 1000 is greater than 1 by 2 to the power of 1001. This can be written as 1 by 2 to the power of 1001, which is less than 1 by 2 to the power of 1000. A positive number. Hence, a positive number smaller than 1 by 2 to the power of 1000 is 1 by 2 to the power of 1001. Hence the result. Number 1, solve for x. If solution number 1, 3 minus x, which is less than 7. Let the inequality be modulus of 3 minus x which is less than 7. We know that mod x or s, anyone? Mod x less than s. Suppose here m, mod m is less than s, then this will implies minus s less than m less than s. This is inequality condition. Modulus of m which is less than s, this will implies minus s less than m less than s. Okay, this is very important. Using the given inequality, minus 7 less than 3 minus x less than positive 7. Now add minus 3 minus 7 less than minus 3 plus 3 minus x less than minus 3 plus 7. So minus 10 less than 3 cancel, minus x less than 4. Now divide by or multiply by minus 1. So we have greater than x greater than minus 4. This can be written as minus 4 less than x less than 10. This means x belongs to, suppose less than or equal to is given, then closed interval will be taken. In this case strictly less than. Therefore closed interval minus 4 comma 10. This is open interval. The interval is open. Bracket is parenthesis bracket. Bracket is parenthesis bracket. Okay. Next question number, subdivision number 3. Solve for x 3 minus 3 by 4x which is less than or equal to 1 by 4. Now 3 minus 3 by 4x is s, m, 1 by 4 is s. This is m, this is x. Then using the formula minus s less than or equal to x or m less than or equal to this, we know that m which is less than or equal to s implies minus s less than or equal to m less than or equal to s. Okay, using the inequality minus 1 by 4 less than or equal to 3 minus 3 by 4x less than or equal to positive 1 by 4. Now adding minus 3, adding minus 3. Why? The middle term plus 3 is given, therefore eliminate this 3. We have to take add a minus 3. So minus 3 minus 1 by 4 less than or equal to minus 3 plus 3 minus 3 by 4 x less than or equal to minus 3 plus 1 by 4. Now taking LCM, we have minus 13 minus 12 minus 1. So minus 13 divided by 4 less than or equal to minus 3 by 4x less than or equal to minus 12 plus 1 is minus 11 divided by 4. Next, multiply by 4. We have minus 13 less than or equal to minus 3x less than or equal to minus 11. We have 13 greater than or equal to 3x greater than or equal to 11 divided by 3. We have 13 by 3 greater than or equal to x greater than or equal to 11 by 3. This inequality becomes 11 by 3 less than or equal to x less than or equal to 13 by 3. Here inequality is less than or equal to. Therefore, x belongs to closed interval. Closed interval 11 by 3, comma 13 by 3. The bracket is closed bracket. Okay. Next subdivision number 4. Mod x minus 10 less than minus 3. Let mod x minus 10 less than minus 3. This minus 10 goes to right hand side, we get positive 10. So mod x less than 10 minus 3. Mod x less than 7. We know that mod m, which is strictly less than s, implies minus s less than m less than s. Okay. Now minus 7 less than x less than 7. This can be written as x belongs to, this is strictly less than. Therefore, using open interval minus 7 comma plus 7, the interval is open. Hence the result. Solve 1 divided by 2x minus 1 modulus, which is less than 6, and express the solution. And express the solution using the interval notation means a closed interval or open interval. Let 1 divided by 2x minus 1, which is less than 1 is less than 6 into 2x minus we have 1 by 6 is less than modulus of 2x minus 1. This means 2x minus 1 modulus, which is greater than 1 by 6. Now we know that mod m greater than s implies minus s greater than m greater than s. Using this inequality becomes minus 1 by 6 greater than 2x minus 1 greater than 1 by 6. Now add 1 on both sides. Add 1. We have 1 minus 1 by 6 greater than 2x minus 1 plus 1 greater than 1 by 6 plus 1. Taking LCM, 5 by 6 greater than 2x greater than 7 by 6. Now divide by 2. Therefore divide by 2. We have 5 by 12 greater than x greater than 7 by 12. Now x belongs to minus x 5 by 12 greater than x. Therefore minus infinity comma 5 by 12 union another open interval 7 by 12 comma positive infinity. This is solution. Next sum number. Solve 2 into x plus 1 minus 6 which is less than or equal to 7 and graph the solution set and graph the solution set in a number line. Let 2 into modulus of x plus 1 minus 6 which is less than or equal to 7. Now this minus 6 goes to right hand side. We have 2 into modulus of x plus 1 less than or equal to 7 plus 6. So 2 into modulus of x plus 1 less than or equal to 13. Divide out by 2 on both sides. We have modulus of x plus 1 less than or equal to 13 by 2. Modulus of m less than or equal to s implies the inequality is minus s less than or equal to m less than or equal to s. Therefore 13 by 2 less than or equal to x minus 1 x plus 1 x plus 1 less than or equal to 13 by 2. This side negative, this side positive. Okay, now add minus 1. So minus 1 minus 13 by 2 less than or equal to x plus 1 minus 1 less than or equal to 13 by 2 minus 1. Taking LCM we have 2 minus 15 divided by 2 less than or equal to x less than or equal to 11 by 2. So x belongs to the closed interval minus 15 by 2 comma 11 by 2. Next draw a graph. Middle is 0. Define 1 2 3 4 5 6. 1 2, 3, 4, 5, 6, and so on to infinity. This side minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, and so on to minus infinity. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Now the interval between minus 15 by 2. Minus 15 by 2 means a minus 7.5. So 7, 8. Closed interval. Okay. Next, right hand side is 11 by 2 means a 5.5. In between the interval. This is graph. Next, sum number 6. Solve modulus of 5x minus 12, which is less than minus 2. Let modulus of 5x minus 12, which is less than minus 2. But the formula is modulus of m less than s, or modulus of m less than or equal to s, or modulus of m greater than s, or modulus of m greater than or equal to s. But in this case, right hand side is negative. Right hand side is from the above inequality. Right hand side RHS is negative, bracket minus 2. So yx minus 12, which is greater than 0, is possible, but minus 2, which is not possible, which is not possible. Not possible means impossible. Therefore, we cannot find the solution. So, the solution does not exist. The solution does not exist. Today homework. EX number 2.2. Sum number 1, subdivision number 2, third sum, and then fifth sum. Only inequalities problem. Okay. Any doubt? Reply the message.